take the highest value. In this case, it's 1660, because my highest contour line there was 1660 meters above sea level. And then you round it up to the next index contour. Remember that an index contour is every 100th contour line. Understand? 100, 200, 600, 800, 1700. Now you round up to the nearest index contour. Well, this is not written in stone, and I will explain a few slides from now why it's not written in stone. You can always change this. Now take the lowest value. In this case, mine was 1380 meters above sea level, and then round it down to the next index contour, which is 1300 meters. Simple to understand. Round down. Understand? Simple to understand. Now this will mark the lowest value on the vertical axis. Understand? A number which is rounded down to the next lowest index contour will be the lowest number on the vertical axis. Understand? Meaning 1300 meters will be the lowest number on the vertical axis, and 1700 meter will be the highest number on the vertical axis. Step 6, construct the upper and the lower limits of the vertical scale. Now, the upper and the lower limit is the most bottom line and the highest bottom line. Now, remember that the number which I rounded off to rounded up to the highest, to the higher index contour was 1700. Can you see that? Can you see the 1700 there on top? The 1380 was rounded down to the lower index contour, which was 1300. Can you see the 1300 on the left side of your screen? Understand? This is how you construct the lower and the upper limits. Now choose a suitable vertical scale. I chose 1 centimeter equals to 100 meters. Look, I'll also explain this a little bit later. The criteria which you might use to choose a suitable vertical scale or vertical interval. Look, can you see the 1700 there highlighted in green on top, 1300 highlighted in green at the bottom? Now, since I chose the scale that 1 centimeter is equals to 100 meters, just put my ruler, understand, throughout, just put my ruler, and this is what I get. That at 0 centimeter, it's my 1300, and 1400 meter is my first centimeter, and then the second centimeter corresponds to 1500, and so on and so on and so on. Can you see the 100 meters in between these 1700 and 1600? Can you see the 100 meter in between? Between 1600 and 1500, there's 100 meter in between. Understand? It's simple. I just did this slide on step 7 to make things visible for you, but you can skip this part where you make things visible for me, because I know what I'm doing. I'll understand if you just wrote something like this. Understand? If you just wrote something like this, I would understand. You don't have to show me that there's 100 meters in between this and this. There is this centimeter, there's this centimeter. You do not have to show me that. Understand? Yes. Step 8. Now find the points of intersection. Now finding the points of intersection is simple. Understand? Can you see the dotted lines there? We have red dotted lines, and then we have maroon dotted lines. Now on the horizontal axis, we have the maroon dotted lines. Understand? Where they cross, understand, with the red dotted lines, understand, then that's where my point of intersection is. Let me make this simple for you. If you're drawing a graph, understand, you all have drawn graphs. For example, in the first test, you've drawn a graph, and with that graph, I know things didn't go as planned. For some of you, it was difficult, but this is the same concept. Let's look at how you draw that. Look at 1380. And you see where the 1380 is at. It's at the beginning. Understand? The 1380 is at the beginning, and then look, it corresponds to that dot on the vertical axis. It's 1380, just below 1400. And then let's look at the 1400 corresponding to the 1400 on the vertical scale. Let's look at the 1460 on the horizontal scale. It's also corresponding to the 1460 on the vertical scale. The 1660 on the horizontal scale is also corresponding to the 1160 on the vertical scale. The vertical scale numbers must correspond to the horizontal scale numbers, and then you put dots there. Now you do not have, obviously, you have to put you do not have to put the dotted lines, understand? The dotted lines are for me to make you understand. If I did this myself, I was just gonna put the maroon dots only. I was not going to put the dotted lines. The dotted lines are for you to understand how did we come to this. Now on page 29, figure 1.28, step 9 for us. Now connect the points of intersections. Now in grade 1 language, it's connecting the dots, understand? You connect the dots, and then if you look at figure 1.28 on page 29, you'll see that they found more or less a side profile like mine. Their side view is more or less this way. Understand? After they joined the dots, after they connected the points of intersection. Can you see that? Okay. Now remember that if you do have a question, just drop your question on the group. If you are in key 1, you cannot post anything because of your behavior towards the group. You DM me directly if you have a question. Now I'll respond on the group because you might find that 2 or more of people have the same question and they want to know what you want to know, understand? But if you are in key 2, key 5 or key 6, you can directly drop your questions on the group. I'll answer your questions on the group, understand? But please, key 2, key 5 and key 6, do not abuse the platform. Do not make jokes on the platform, understand? It's a geographic group, understand? People do not have data to open your messages which are not related to geography. Please respect the group. Now the same thing, this is still step 9. I just removed the lines, I've drawn it, it's fine. Obviously things will not, you're not going to be as accurate as I have been. Well, I was not even that accurate, understand? But the point is we get more or less the same shape, and use a free hand. When I say free hand, I'm not referring to the hand which has nothing on. I mean like draw with the pencil. Do not use a ruler because in real life landscapes are not really straight, understand? Use the free hand to draw the cross section. Now labeling the axis and naming the cross sections. I've named my cross section AB and then Phillipstown 24 AD. Now that's just the name of the map which I found the cross section at. Most people will just name cross section AB. I say name the cross section AB Phillipstown 24 AD in case someone wants to find out which map did you find such a landscape, understand? Maybe someone wants to start a tourist company and this is a nice landscape. Where is this landscape? Now they'll just read Phillipstown 24 AD and go to that map and trying to find that section AB. Now labeling the axis, the vertical scale, obviously mine was 1 centimeter is to 100 meters, and then the horizontal scale remains 1,000. It remains 1 is to 50,000. Why is it 1 is to 50,000? Because we are using a topographical map, people, understand? If we are using an orthophoto map, our horizontal scale was going to be 1 is to 10,000. We fine. Step 10 is step 10, fine. Sharp. Now, obviously, the vertical scale can also be written as 1 is to 10,000. Why is the vertical scale can be written? Why can we write the vertical scale as being 1 is to 10,000 instead of 1 centimeter equals to 100 meters? Because 1 is to 10,000 is like saying 1 centimeter on the map is equals to 10,000 centimeters on the ground. Understand? This also means that 1 centimeter on the map is 100 meters on the ground. Understand? Because we converted. Remember that when we are converting for distance on an orthophoto map, we said 1 centimeter multiplied by 0.1 kilometer. Understand? We'll convert those centimeters into kilometers. If we wanted to multiply the centimeters and then get them into meter, what could we have done? We could have just taken the 1 multiplied by 0.1, and then you get the answer in kilometers, and then you multiply by a watt. You know the conversion factor, by 1,000 to make it meters. Understand? This is the same concept. Now, using conversion factors of 100, meaning that I'm converting